Hello and welcome to this second video on our deep learning Easter egg hunt. Today we're talking about labeling, and my take home for today is to not label manually, label smart. There's a lot of iteration and repetition that we can remove from this process, and I'm going to show you how step through some of the problems and how we can automate to help that go away. So the first problem we find is you're dealing with lots and lots of different data. In this case, image data stores are your friend. They are pointers to the data, and as you can see, it's found there's the 100-odd files here that we're going to work through. They're pointers, they don't actually load the data itself, so they can scale out to terabytes worth of data. We can then use data stores to iterate through them, or we can read individual files out of them. So here I'm reading a single image out of my data store, and no surprises, this is what I plotted, what I showed in the time lapse taking the photos of eggs on my desktop last week. I'll then just reset that data store back to its beginning. So the next question then is we've wrangled all this data, but how do we actually do the labeling? Well, the way we do that is we have an app to help us here, the Image Labeller App. This is what it looks like. It's, I think, fairly friendly to use. We start off by defining our labels. In this case, we're going to be labeling eggs. We can have as many or as few of these as we like. We then pull some data in. So I'm going to pull in some images from the data set. Only a few images, contains only 10 images, so just so we can see how the process works. Now what it's doing is it's parsing that data, reading the first few in, pulling some samples in and displaying some results here. And we're actually good to go. So with a couple of clicks, I'm actually now labeling. And in 30 odd seconds as I'm talking here, I've labeled my first frame. We can do it. It works. You could see it would be getting a bit tedious after a little while. And I've only got the first 10 of the 100 odd images here. Once we're done, we export out as we would normally expect. But the key that I want you to take home is I think we can do this smarter. So I'm going to go back and discuss what I mean. Let's go back to the workspace and have a look at it. So the next step to look at is if I scroll down to the next live editor script here, this is based on my experience in industrial and production contexts. We often know a lot about the images that are coming through. We can look at colors, we can look at shapes. It might be a bag coming down a production line, a bolt on an actual bolt or a widget coming down a production line. We know a little bit about it, so we can pull some off-the-shelf image processing tools to help us work through. So I'll quickly pull this up as I'm talking, and you can have a look at what I mean. So this looks like that same labeling image again, but I've got some automation behind the scenes here to really quickly allow me to iterate. Now, how much quicker was that? Okay, well, this is split into two components. There's the auto bound function, which is boilerplate. It doesn't change. And then there's a pre-processing step that I plug into auto bound to make this go. So how did I do that pre-processing? Well, I know a lot about these eggs. I know they're fairly consistent colors, so I pulled out 5 or 6 lines of compute code here using standard image operations. So we're downscaling to gray, we're doing an edge detect with a Sobel edge filter, and then we're doing some image operations to join those up. But the key to take home here is I've now converted this process into some functions. So the real power of that image labeler that I just showed you is not that we can draw labels by hand, it's that we can pull in those automation functions and use them to make our life easier. So here's a session I set up earlier. And the way we do this is we have this additional tab up the top here, which allows us to plug in some automation algorithms. So I've got some boilerplate code here. We pull that in and I've now created an automation algorithm. Let's grab all 10 frames. Let's click automate. And the way it does it, the additional step here is I need to put in an auto bound function. So in exactly the same way you saw that auto bound on my code, this is exactly the same code. I've just created an anonymous function. I copy and paste into here, click run, takes a second to pause, we're up and going. And then I can now swipe on my code here. So I've used a little bit of knowledge about my workspace to rapidly speed and iterate. Now you might have noticed as I'm going through here, a couple of those eggs aren't working. And this is where I come back to that iterative procedure. So let's push this into place. Let's stop. Let's go back and have a look. Accept. So this is where the iterative part of this procedure comes into place. We can come back and tune those. We can come back and tune those labels that are created for us by starting to train some detectors. So I went through and did those 10 frames. I've now got from those 10 frames, I've got 50 or 60 odd images. So we can actually start to train ACF detectors. Now, the reason I start with an ACF detector is ACF detectors are not nearly as good as, say, YOLO detectors or the current state of the art in the CNN object detectors, but they're quick and dirty and forgiving. So we can see here with only 10 labeled frames, I've been able to train an ACF detector, and I'm going to finish on the kicker here. Remember, I can convert these ACF detectors into functions. So I can feed that function back into MATLAB to label more images faster, which I come back and fix up and tidy up. And I repeat this process, and suddenly I've got an automation algorithm that has rapidly labeled all my images for me with a little bit of tidying around the edges, and I'm ready to go with my proper training of a full deep network on a fully labeled data set. So that's the kicker. Remember, iterate and automate. Don't do this by hand.